All right, we are looking at ionic compounds this week with ionic bonding. Okay, so I'm going to give you an example with salt. Just normal, everyday table salt. Okay, NaCl, sodium chloride. We need it in our bodies. Okay, it's crucial for our nervous system, our muscles to fire, fluid levels in our body. Okay, we have to have it. It's all around us. We put it on our food. If you make bread without salt, it's flavorless. Okay, so it's essential. We have to have it. Yet it's made up of two compounds, sodium, not compounds, two atoms, elements, sodium and chlorine. Okay, when you combine this, it's called chloride. If you take sodium, sodium we say is a metal. Okay, here it is. Okay, it's got to be stored. It's very reactive metal. It's got to be stored in oil because it's so reactive. It reacts with water, which maybe we'll show you in a minute. If I cut it in half here, you can maybe see. Yeah, I can go a little closer here maybe. I don't know if this will work. You can see it's a shiny metal, right? Okay, so you don't want to think about sodium if you don't think about it that way. Okay, so it's quite reactive, right? And you get it on your skin, it would react with your skin. Okay, put it in water, it should be very reactive with water. So I'm going to try this. I found this old glass. No, it's worthless. It's got OSU on it, so it's expendable if something happens to it. Okay, so we're going to put the sodium in there in a minute or so, see what happens to it. But it combines with chlorine. Okay, so chlorine gas is a yellow poisonous gas. It was used during World War I as part of chemical warfare. Okay, it's a dense gas. It would get into the trenches and it would cause lung problems, cause the lungs to turn acidic and fill up with fluids and death. It was kind of a nasty death. So you can see here this actually isn't chlorine gas. It's something similar to it, but you can kind of see if I open this up, you can see it kind of pours out a little bit like chlorine gas would. This is not chlorine gas, but it looks kind of like it. Okay, so it's a yellow poisonous gas. So we're going to take sodium, which is a very reactive metal, and chlorine gas, put them together and you make salt. Okay, so let's look what happens with the sodium. So finish out that little demonstration. Okay, so I have here just water, and I'll take these pieces of sodium. I'm going to place them into the water, and then let's see what happens. I'll place them in here, and then I'm going to get out of the way. You can see they're kind of flitting around there. Pops a little bit. There we go. Little fireworks for you to start off your week. All right. So let's get into the study of ionic bonding. All right. So that was a bit disappointing. So let me try it again. Again, here's the chlorine gas. You can see it's a little bit better, but it's white background. You can see how it comes out and then kind of goes down. You can see that filling up the trenches and causing problems in trench warfare. All right, put this to the side now. It is a little bit smelly. You know, it's not actually chlorine gas. All right, then I have my sodium. I put a little bit more sodium this time. So I'll place it in there. Let's see what happens to this. This time around. All right, we got a little fire there. Come on, keep going. There we go, a little bit better. All right, have a great weekend, stay safe, and study hard. Okay, let's get into ionic bonds. Okay, so this next unit, the next couple weeks is going to be We're chemical bonding. Okay, so there's actually two major types of bonds. One is ionic and the other is covalent. Okay, covalent means to share electrons, and ionic means there's a transfer of electrons and it creates ions. That's why it's called ionic bonds. Right? So this week we're concentrating on ionic bonds, and next week covalent. All right? So in general, bonds, okay, they're a force holding atoms together. Now you should have access to this note sheet without the writing on it. So you can pause anytime and fill out that sheet, or you can just fill out a sheet, notebook, piece of paper. That'd be fine also. All right? But a bond is force holding atoms together. Okay? Things react to become stable. Atoms are stable when their outer shells are filled with electrons. Okay? So if you have an atom like helium, neon, argon, their outer shell's already filled up with electrons. Okay, they're content, they're happy, they are unreactive. They're good by themselves. Okay, but other atoms tend to form compounds or combine with other things with these bonds to become more stable. All right? So the general rule is chemically stable, outer shells filled with electrons. A lot of times they call that the octet rule because that generally means their outer shell has 8 electrons in it. Okay? Octopus, octet, those are 8. Okay? So that's the general rule. That's what atoms try to get to become satisfied. All right. So ionic bond. That's what we're looking at today. Ionic bonds. Okay. Ions. So you form ions. It's due to a transfer of electrons. Okay. So our friend salt. Okay. So we'll start off with sodium. Sodium is symbol Na. Okay, it's got 11 protons, and we're going to start off with 11 electrons. Okay, so nucleus right here. We'll fill in those electrons, 1, 2 in the first shell, 3, 4, 5, 6, 7, 8, 9, 10, and then one more makes 11. So you can see with sodium, it could either gain 7 more electrons to become stable, which is relatively unreasonable, or it can lose 1. Let's get rid of that one. So now, instead of being 11 protons, 11 electrons, we're going to make that 10 electrons. So now when you have 11 plus charges and only 10 negatives, it's going to give it a positive 1 charge. Now that can go 1 plus, or sometimes they just put a plus sign, and the 1 is assumed. We say that is they call that the oxidation number or its charge. Okay, so that's sodium would be a positively charged ion. Okay, so generally all metals will form positive ions because they have extra electrons and they just try to get rid of them. Okay, so that's sodium. So look over here at chlorine. Chlorine is, of course, a nonmetal. It's in that second to last group. That's called the halogens, along with fluorine, chlorine, bromine. Okay. So it's got atomic number 17. So it's got 17 protons, 17 electrons. So this, of course, the protons are in there. I'll draw in the electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 11, 12, 13, 14, 15, 16, 17. Okay, so you see in chlorine's case, it can either lose 7 or gain 1. Of course, it wants to gain 1. That's a lot easier for it. Okay, and you can see the sodium could be the donator. Okay, so it grabs up that electrons because it wants to suck it up. You get it? So now we're going to have 18 electrons. So now, of course, you see what's happening here. 17 protons and 18 electrons now. So we're going to give chlorine, Cl, a 1 minus charge. And you know now, sodium, positive, chlorine is a negative. They will form a bond. So you would call that, of course, an ionic bond. Okay? A bond between ions. All right? Now, when you draw these numbers up here like that, they call those oxidation numbers. Okay, it's a big word for what the charge is on the atom. Okay, so technically it's the number of electrons lost or gained by an atom. Okay. And then when things combine, here's the rule. The big rule is the sum of the oxidation numbers has to equal 0. Okay, so when you add them all up, okay, you vary the numbers of them so that it comes out to be a 0 charge. All right? Now, it's an easy way to figure out what the charges or oxidation numbers are going to be. So again, you should have access to this ion chart in your Google Classroom. And if you look in this periodic table, everything in group 1 is going to be a 1+ charge. Okay, we just went over sodium, but like sodium, we have lithium, hydrogen, potassium, rubidium. They all are going to have a +1 charge. Everything in group 2 is going to be a 2+ charge. These transition metals here, you do have to look those up, but on that chart they tell you what they are. It's a little more complex. You can't just guess by the group. Okay, but they're all going to be pluses. And then over here, okay, group 3A here, 3+. Okay, now this is kind of right in between. Okay, so we're just going to say ±4 for that. Okay, generally they form covalent bonds anyways. And then here we have -3, -2, -1. Okay, chlorine right here, it's a -1. And then of course these noble gases, they're going to be zeros because their outer shell is already filled up with electrons. Okay, so you always have access to that so you can figure out what those oxidation numbers are. All right? Now let's move on. Okay? How do we know what the correct formulas are? All right, so here are the rules. Okay, formula tells you the number and type of atom. All right, so for example, water is H2O. That tells you have 2 hydrogens and 1 oxygen. When you have water, it's not an ionic compound, but H2O, that's the number of atoms is written as a subscript. Okay, because with your oxidation numbers, you write things as it's called a superscript. So H2O means 2 hydrogens and 1 oxygen. You're familiar with that. All right. So here we go. Formulas, number and type of atoms. Here's the rules when you write the correct formulas. Okay. Always write the positive ion first. Okay. So if I have magnesium and fluorine together, magnesium, if you look it up in the chart, it's in group 2, so it's a 2+. Then you write the negative ion. Let's see, it combines with fluorine. That's a 1-. Okay, so when they combine, it's going to be 1 magnesium with 2 fluorines because you need 2 of these to balance that 1. Remember, the sum has to equal up to 0. Right? Another example, say aluminum and oxygen. Well, if you look up aluminum, Al, it's a 3+. Oxygen is a 2-. Okay. So when they combine, it has to equal 0. Okay, so you would need Al2O3. Okay, you have to think of a whole number. They both can go into 6 evenly. Okay, so 2 times 3 is 6. Okay, 6 positive. 3 times -2 is -6. That would balance. Okay, you can also kind of look. You can just cross those numbers over. That's kind of a little bit of a cheat, but you can always do that and reduce to the simplest ratio. All right. All right, so that's in general how you write correct formulas. Okay, binary compounds is when you do just 2 elements, like we did here. Okay, there's more than 2 atoms, but they're just 2 elements. When you name these compounds, it's the full positive, root of the negative, then you add IDE. So with sodium and chlorine, you don't call it sodium chlorine, you call it sodium chloride. That's table salt. Here you would go magnesium fluoride, aluminum oxide. All right. Finally, polyatomic ions. Polyatomic compounds or ions are groups of atoms acting as one. All right. So there's quite a few of them. Okay, so if you look at your periodic table, you can see at the top of this table of ions here, you can look up these common polyatomic ions. All right. So today we're going to look at, for example, nitrate. So nitrate is NO3, which means it's a nitrogen with 3 oxygens, okay, but it just acts as one ion, so it's got a 1- charge. Okay, so if you look it up on your periodic table, you look up here, got to be kind of specific because there's nitrite here, but nitrate, NO3 with a minus charge, all right? So I like to put a 1-, but you can also just be a minus, and that 1 is assumed to be there. So you can look up all these polyatomic ions, so you'll have access to that. But it does kind of throw a wrinkle into how you put things together at times. Right? So let's look at how you would do that with a couple examples. Okay, so here's nitrate with a NO3 1-. Okay, so for example, you had potassium nitrate. You look up potassium, potassium is K with a 1+. Nitrate is nitrogen with 3 oxygens with a 1-. Okay, so again, there's a total of 4 atoms here, but they act as one. But it's the same rule. You have to add these up to make it equal to sum is 0, so it just would be KNO3. Okay, 1 potassium. Now you got to put numbers down there. If it's a 1, they're assumed to be that. All right. Okay, so that would be potassium nitrate up there. And here, magnesium nitrate. This throws a little wrinkle into things you have to be aware of. You look up magnesium. It's Mg. It's a 2+. It's in group 2. Nitrate is, of course, a 1-. So when you combine them, you would get magnesium. Always put the positive first. Then the nitrate. Now you can see this is a 2+, this is a 1-, so they come up to 0. You need 2 of these to balance this. So if you put a 2 down here, well, that looks like 32, which obviously that would be ridiculous. Okay? So when you put a number other than 1 on a polyatomic ion, you have to put a parentheses around it. So you put a parentheses around the NO3, so that means take 2 of that whole thing. So it would be magnesium nitrate, but 2 of that group.